design OR gate using a GPDK 180 nanometer 3 input NOR gate. First we have to build the circuit like this. So all NMOS devices are parallel and the PMOS devices are in series, and you have to connect this. All bulk of NMOS will be connected to the ground. All PMOS bulk should be connected to the higher potential or source of the PMOS. Take power supply from analog group VDC to Spectre mode. Select here. And give the voltage as 1.8. Ground pin has to be selected from the library basic. Choose small G and D ground. Keep it here, it's a common ground. And input and output pins you have to decide. So input first we decide 3 inputs, so A, B, C. A, B and C inputs are given, and the output we have to read. So we have to give output pin also. Time to dash Y or out as I wish. So I am keeping output at this end. So So now the schematic of this 3 input NOR gate has been built, and do check and save. If any warning is there, we have to clear. Yes, warning because of the bulk as PMOS has not been connected to the source of the PMOS. So you connect it directly, or you connect like this also. Since we connect like this, we come to know whether we are done or not. Connected PMOS to the higher potential. Do check and save. Now there is no error, and you can simulate using ADO screen. Here same procedure, transient analysis, and give 200 nano as the input, and output to be platted. You have to plat all the inputs as well as output. A, input B, input C, and as well as our output. So everything will be displayed here in the ADL window, and you can see this. Okay, now once it has been done, go to output, save all, same procedure, click this all power and select the signals, everything, and then the last format has to be modified into PSF, that you should confirm it. So PSF also checked, give apply and OK. It's the first procedure before doing simulation. So keep all the waves are in save format, and we have to do inputs here. Before doing inputs, and we must understand how we can give the inputs. See, this is the NOR gate, okay, schematic, and as well as the inputs. Without this red box, you can see the inputs for 3 inputs A, B, C, all are 0. In NOR gate, the output will be 1 because it is sum of all the things in it. So y equal to A plus B plus C whole bar. So obviously all the things will be 0, so bar will become 1. So when all the inputs are 0, output is 1. So this is the case. All blues are the real output schema, output logics for NOR gates, and the reds are the inserted inputs, zeros. So all zeros are inserted here, and the output Y become changed. This is the inputs are inserted. Why? Because we need either falling edge or rising edge for each steps. So we can calculate the delay. So we can calculate the delay for every steps. So these inputs can be written in different ways also. So now I have included zeros in between, so that first stage of 0 to 1 falling edge. See, I am giving arrow mark here. It is a falling edge of output. Sorry, a rising edge of output. Here in this case, only C can have a falling edge. See, remaining two things, A and B, don't have any falling or rising edges. Only C contains falling edge, and output contains a rising edge. So that because of this reason, falling edge F1C, comma R1Y, this kind of delay for two things you can calculate here. Like that, you have 7 methods to calculate, and you have to feed the inputs like this. The input where I inserted zeros, so there I am keeping here. So you have to give the inputs through stimuli to find out the delays as well as power. So we have to give this exact input, so you can have the similar outputs for all the students. So this is pause it and please feed the datas in the stimuli. So totally 1, 2, 3, 4, 5, 6 zeros, and then all 1010s. So I am going to queue now. So just choose stimuli and select input A and follow the steps. 1.8, 0, and rise time, fall time, PQ 500 pico, and period you give 10 nano, and pattern you should copy from there 1, 2, 3, 4, 5, 6 zeros, and 1, 0, 1, 0, 1, 0, 1, 0. So these are the input for A I have given, applied. And next B, so I have to check the B input. So 0, 0, 1, 0, 1, 5 zeros. 0, 0, 1, 0, 1. The pattern 0, 0, 1, 0, 1, and then 5 zeros, then 1, 0, 1, 0. So as usual again 1.8, 0, 500 pico. Here also 500 pico. It's getting hanged.